Hi guys, Mr. Kane here,
Hi guys, Mrs. G.
and we're about ready to do some titrations.
Yep, okay.
So might as well get straight away.
This is fun.
Yep. Basically, a titration is going to be an experiment that's designed to determine what the concentration of a known volume of acid is by neutralizing it with a certain amount of base, measured amount of base.
So in our picture there on the right, in the Erlenmeyer flask is an acid, an unknown concentration of acid with an indicator in it, right?
Right. Yeah, so we found a stock bottle in the back. We don't know what's in it.
Yeah. We've got a burette that's attached to the ring stand that usually sodium hydroxide, which is a strong base, and usually a concentration we know, typically 0.1 molar. And we pour a little bit of the base into the acid, into the Erlenmeyer, and we swirl until the color changes.
Mm-hmm.
Okay.
Yeah, and we use an indicator to help us out because different indicators have different color changes. In this particular case, we want phenolphthalein because we want an indicator to change at neutral.
And a strong will be 7.00 pH neutral. Yep.
Right.
As long as it's a strong and a strong.
So phenolphthalein turns pink when it is a light pink color when it's at its end point, when it's at neutral.
When it's kind of a little slightly on the basic side, just a smidge.
Right. So you want to be kind of careful. When we're actually doing this in lab, it's going to be clear because it's going to be acidic. As you add sodium hydroxide dropwise, you're going to notice that it's going to change just where the drop of sodium hydroxide hits pink, and the pink color is going to go away. At first, it's going to go away very quickly, and as you continue on, it's going to go away slower and slower.
And the closer you get to the end point, the darker that pink droplet is, right?
Mm-hmm. Yeah, it stays pink longer.
Yeah.
So it appears to be darker. Now you want to end when it's light pink.
And stays light pink.
And stays light pink. It does not change back for about 10-15 seconds or so.
Yeah, it's got to stay light pink when you swirl it.
Right. If it goes to dark pink and stays dark pink,
you've gone too far. You got excess base.
And you got to start all over.
Yeah, you don't want to do that. Your end point is where your hydrogen ion is equivalent to the hydroxide ion. It is neutral, equal.
Right, which is where we can do the calculation.
Right.
Right. And the whole calculation for titrations is pretty simple. The calculation is
MAVA is equal to MBVB, with MAVA being the molarity of the acid and the volume of the acid in the Erlenmeyer. Of course, your MA would be your unknown, being equal to the molarity of the base and the volume of the base that you put into the Erlenmeyer, which would be your knowns. 4 variables, 3 known, 1 unknown.
All right, so for example, right?
For example,
if we did a titration and found that 20.1 milliliters of 2.00 molar sodium hydroxide is needed to neutralize 10 milliliters of hydrochloric acid of unknown concentration, what's the unknown concentration? Well, we're still going to use this equation that we just talked about. MAVA equals MBVB.
The nice thing about acid-base titrations, Mr. Kane, is they're all 1-to-1 ratios. There's the beauty of it all. You don't have to mess with coefficients or nothing.
No, there's nothing here. Yeah, there's nothing to mess with here. So we're looking for the molarity of the acid, so I'm just going to label that as M.
That's our unknown.
The volume of the acid, well,
given in the problem.
That's 10.0, right?
Right, in milliliters.
In milliliters. I'll do units this time, milliliters. Molarity of the base, well, it's given as 2.00 molar solution.
Right.
Right. And then we get 20.1 milliliters as the volume of the base.
Now, just a little concept here, Mr. Kane, see if we understand this right.
All right.
Technically speaking, acid base are going to be equal to each other, right? If they were going to be the exact same concentrations, then you'd have to have the exact same volume of both to be equal.
Right.
Now, I'm looking at a 2 molar sodium hydroxide, 20 mils approximately, but it neutralized only 10 mils of HCl. So I get the feeling these are not going to be the exact same concentration.
No, they're not. They can't be because there's twice as much.
Yeah, there's technically twice as
base.
much sodium hydroxide.
So I'm thinking that this is going to be
twice as much acid.
Twice as much acid.
So around
molarity.
the 4 mark. Okay, let's try it.
So let's see. So 2 times 20 is going to be about 40.2 molar times milliliters. And my MA here is still going to be multiplied by my 10.0 milliliters. I'm going to divide both sides by 10 milliliters.
Which is algebraically correct.
Milliliters and milliliters are going to go away. So 40 divided by 10, well, that should be about 4.02 molar solution.
And that's the concentration of our acid.
And that's going to be our MA.
That's exactly what we conceptually said.
And yeah, that is pretty much what we said, isn't it?
Yep, doesn't get any harder than that. Awesome.
Okay, very good.
That's it.